I welcome you to this video. In this video, I'm going to be explaining to you the foundation settings you need to know before you carry out your foundation design, okay? Before you carry out your foundation design, there are some settings you need to do. As you can see this structure, you can see that we have done our analysis and design on the superstructure, and we have checked all the design and it has successfully passed, okay? As you can see here. So before you carry out your foundation design, the first thing you have to do is to go to story 0, okay? Then once you get to your story 0, you go to your settings center, okay? Just make sure you do your settings first before you do any foundation design, okay? Then looking at my cursor here, you see foundation here, okay? You click on the foundation, okay? Then you see this foundation dialog box here, okay? Then you see this under allowable stress of soil here, okay? You make sure that you follow what is given to you by your geotechnics engineer, okay? In my own case, I have 175 kilonewton per meter square, okay, which is 175 kilonewton per meter square. I'm going to enter that. Then under this soil vertical subgrade coefficient, you leave it as default, okay? You always leave it as default. And if you have another value, you can always input the value, but I advise you to always leave it as it is, okay? This value, this default value is a value given to us by a professional, okay? As you can see, this is a reference by Foundation Analysis and Design by Joseph E. Boyce, okay? So I advise you to always leave that as it is, okay? Then, under this lean concrete thickness is our blinding, okay? This is our blinding. I can choose to use 50 mm, Then your strip footing cantilever length. This is majorly for wide strip foundation, okay? It's for wide strip foundation. You can leave this. Then your default pad footing form should be, I always advise you to use square, okay? You always use square for that, okay? Okay, so you set your allowable stress of soil to 175 or any value given to you by your geotechnics engineer. Okay, you see this allowable soil stress ultimate strength factor is your factor of safety, okay, which is 1.4 according to our BS code 18110. Okay, you leave this value this way. Okay, then your soil vertical subgrade coefficient, don't forget, you leave it this way. Then the lean concrete thickness, our blending thickness in Nigeria here, you should always use 50 mm or within 50 to 100 mm, okay? Your strip footing cantilever length, you leave it as it is, rather. This is majorly used for your wide strip foundation. Then also, your default pad footing form, always, I like using square, so I advise you to always leave it at square. Then you come to design here. Under this design, you can go to your minimum pad footing width, okay? I also advise you to always leave this at 1000 mm, okay? That's fine. Then minimum pad base depth. For me, I always like to use, let me say, between 300 to 400 mm, okay? At least whenever you are designing, you should always also try to be economical, okay? Then, once you change this, your maximum steel spacing size, I always like to leave this at 250, okay? Then size increment step, this is 100 mm here. What this does is that if, let's assume you have a pad base of 1000 mm and it's not working or it doesn't pass, then it means the size increment step is going to increase. You can only increase it to 1100, 1200. It's going to be an 100 mm additional. Then if you change it from here to 50 mm, then it's going to allow you to change it from 1000 mm to 1050 mm, 1100 mm, 1150 mm. Okay, same thing applicable to the depth increment step. As you can see, I have 300 mm here. If I leave this also to be 50 mm, then it's going to give me or allow me to also increase from 300 to 350, from 350 to 400, from 400 to 450 till I get to the particular depth that will pass. Okay, that's fine. Then this footing reinforcement, always leave this to with Bob. Okay, then your minimum steel bar size for hard footing should at least be Y12. Okay, then when you now do it and it doesn't pass, then you can now change it to Y16. You can also leave this to be Y12. Whenever you are designing, you make sure that you design for safety, serviceability, and economy. Okay, it's always good to leave it at Y12. Then when the particular base does not pass, it may not pass when you have maybe you have a wide or a long pad footing base. Okay, then use top bars. I advise you that you should always uncheck this one. This also works when you have a combined pad footing. Then you can always check these top bars. Okay, then the next thing you have to do is to click on OK. Then I always advise you to save your settings. Whenever you do any settings, you save your project, okay, so that it's going to apply that new setting. Then once you have saved your project, okay, then you can click on any column, then you right click and say insert pad footing. Then you give it time to load. Okay, once you attempt to insert your pad footing, then as you can see, if you remember, we set the depth of our footing to be 300 mm, okay, and this is it right here. Then your concrete cover, let me go back to that settings, or let me go to, let me see, setting center. Then I will go to, at your setting center here, you can also change your concrete cover to 50 mm, okay. If I change it to 50 mm here and click on OK, and click on save again, then if I also click on one column again and right click and say insert pad footing, give it time to load. Then right here you see that our concrete cover has changed to 50 mm. Okay, as you can see, for this particular column, 1000 by 1000 mm footing is going to pass. As you can see here, it's going to pass. Okay, what if I decide to reduce this depth size to 250? Can you see? Let me click on design. Okay, let me click on 250 again. As you can see, 250 is still passed. Then instead of using 400 mm or 300 mm, if it's not going to pass, then it's going to tell you here that design has failed. Okay, then what if I go to 200? As you can see, with that allowable stress of soil, the depth of 200 mm is still okay. Then the next thing you have to do, you can always increase your size from here. If you look at my cursor, you see that my LX is ranging from 1200 to 1250 to 1300 to 1350. Assuming I leave the depth increment step or the size increment step to be 100 mm, this will be changing from 1300 to 1400 to 1400 to from 1400 to 1500, and it's not going to be showing me 1450, 1550 and others the way it's showing me. Okay, then you can always relabel your pad footing label to BT1, which is base type 1, base type 1, okay, base type 2 and others. Then after you are done with these settings, you can always come to your 3D to view your design in 3D here, okay, so that you can actually see what you are doing. Okay, you can also go to you don't need to do anything on your pedestal here. You don't need to do anything. Let me change this back to 1000 mm. I'll change this right to 1000 mm. As you can see, 800 mm size is not passed. This is design has failed. Okay, let me increase it a bit to 1000 mm. As you can see, because we have set this to 1000 by 1000 mm as our minimum size, that is why you can see that it's bench it to 1000. Then I will also click on force square footing for design. Okay, I will set it to that. Then you can always go to your materials. Then you can also change your concrete grade here, and this is your rebar, which is set to 410. Okay, you can always do that here. you can see that we have ultimate stress of soil to be 245. If you remember our, let me click on my calculator. If you remember, our design allowable stress of soil is 175. Then if you multiply this by ultimate strength factor, factor of safety, multiplied by 1.4, you are going to get 245, which is this ultimate stress of soil here. Okay, this is how this value is gotten. Can you see that? Okay, this has been factored by 1.4. Okay, I can close this. Then you don't need to tamper any other settings here. You leave it as it is. Then you can also go to your option. If you go to that option, you can still come here to set your link concrete thickness, your size increment step, which we have done before. Okay, you don't need to do anything here. Your bar spacing step, you can leave all this the way it is. Okay, if you go to your column loads, it's going to show you all your load combination used to design this pad footing. Okay, then you can always come to your rebar. Then on this rebar here, you can do some settings at this point. If you look at this rebar X, this is our bottom bar on X and Y direction, and the diameter is 12 mm. As you can see, it's 12 mm, while the quantity is 3. This is 1, 2, 3. As you can see, 1, 2, 3. Can you see that? Then the spacing is set to 200 mm. What if I change the spacing here to it's set to 250 before? What if I change it to 200 and click on design? Can you see it has designed it to be 200 mm, which is fine. Then this distribution bar doesn't really need it. You can only use distribution bar when you have a top bar. If I check this top bar here, you see that you now have a top bar right here. Okay, can you see that? Let me click on design. Can you see? Can you see that we now have a top bar right here? But for a depth of 300 mm, I don't think for a depth and for a breadth, length and breadth of a 1000 by 1000, I don't think you need a top bar. Okay, you should always try to maintain safety, serviceability, and economy whenever you are designing for your client. Okay, for this you don't need. Okay, let me show you something. As you can see here now, we have a top bar both in X and Y direction. I can also check this distribution bar now to have a distribution bar, since I have what is it called? Can you see that it's not even allowing me to check because the depth is very small? Okay, the depth is very small. So for this depth now, it's not allowing me to use a distribution bar. Okay, so for this, I will uncheck these two bar back. Okay, I will uncheck it and I will click on, once you are done with that, you can go back to your geometry. Then you can now click on OK. Once you click on OK, it's going to design your pad footing. As you can see, we now have a pad base type 1 at 1000 by 1000, okay, with depth 300 mm for this particular one. Then you can always design for every other columns the way you do for that. If I click on this also, I will right click and I will say insert pad footing. Then I can always do my settings. I'll click this to be, I will force the square footing, and as you can see, this allows me to use 850 by 750 based on the loads on the column. Then I can change it from here if I wish to 1000 by 1000 mm, or you can use 800 by 800. Okay, you can use 800 by 800. I will check this first square footing for design. Okay, I'm going to leave this depth the way it is. Okay, then this eccentricity here, I can set this eccentricity, which is not really common. If I set this eccentricity, this column will move to another position. Let me set it to 400. Okay, as you can see, it's even telling me that design has failed and my column has shifted. Okay, then you change it here back to 0, then your column will be at the center. Okay, when you click on OK, you see that it's going to design your column for you. Then if you save this project, you can now design for every other column the way it should be designed. Okay, this is where I'm going to stop for now. Please always make sure that you design and you do appropriate settings. Thank you very much. See you in my next video.